Let's talk about something huge happening right now. Companies everywhere are falling all over themselves to hire AI developers. But here's the problem. Their interview process, it's often totally broken. So today, we're going to dig into what really separates a good AI developer from a great one, and how interviews need to change to actually find them.
So, what's at the core of this issue? Well, most tech companies are basically running their standard software engineering interviews for AI roles. But as we're about to see, these are two very, very different jobs, and that little misunderstanding is leading to some incredibly expensive mistakes.
This quote it nails it, doesn't it? Everybody's talking about a talent shortage, but that's not really it. It's a filtering problem. Companies are accidentally screening for the wrong skills, asking these textbook questions that test memorization instead of a real, honest-to-goodness problem-solving ability.
And let's put a real number on what happens when you get this wrong. A big one. One company we know tracked the cost of a single bad AI hire. An engineer who was great in theory, but couldn't get a model out of a research notebook, and it cost them over $300,000 in wasted time, rework, and project delays. Insane!
And you might think that's just a one-off, but it's not. The data shows that about 23% of these super expensive AI hires end up underperforming within just 6 months. That is nearly 1 in every 4. So yeah, the stakes here are incredibly high. All right, so how do we start to fix this? Let's begin with the basics, the stuff that interviewers love to lean on. This is the foundational knowledge, the absolute bare minimum entry ticket that any serious candidate should have down cold.
You know the one. A classic opening question is just explaining the difference between supervised and unsupervised learning. A good candidate should easily tell you that supervised learning uses labeled data, like, say, a bunch of emails already marked as spam, while unsupervised learning is all about finding hidden patterns in unlabeled data, like grouping customers by their shopping behavior. It's important for sure, but it's really just step 1. And here's another classic. What is overfitting? That's when a model gets a little too good at the training data, so it aces the test but completely fails on new, real-world data. The textbook answer usually involves things like regularization or cross-validation, and frankly, any candidate worth their salt should know this in their sleep.
But here's the crucial point. Nailing these kinds of questions just proves you've read the book. It doesn't prove you can actually build anything that works. The real work, the messy, unpredictable, high-stakes work, that all begins the second that model leaves the safety of the lab and gets deployed into the wild.
And this is it. This transition from the clean world of theory to the chaotic reality of production is where most candidates just fall apart. We're now in the world of MLOps, machine learning operations, and let me tell you, the gap between a model that works and a system that's truly production-ready is massive. This is what separates the notebook engineers from the pros.
I mean, this says it all, right? It's a fundamental difference in mindset. For the notebook engineer, their job is pretty much done when the code runs successfully on their laptop. But for the production engineer, their job begins when that same code breaks in the real world, usually at the worst possible time, like 2 in the morning. Their real value is in being able to diagnose and fix things under pressure.
So, forget the textbook questions. Imagine asking a candidate this. Okay, your model's response time just shot up by 700%. What do you do right now? A great candidate won't just stammer out a technical answer. They'll walk you through a calm, methodical process for diagnosing the problem, starting from the server infrastructure all the way up to the model code itself. Because this is the reality of the job. It's way less about perfecting some fancy algorithm and way more about managing real-world chaos. We're talking about handling model drift when your user's behavior suddenly changes, or schema drift when the data you're getting is suddenly in a different format. It's about building robust CI/CD pipelines specifically for machine learning. This is the 80% of the work that almost never gets talked about in interviews.
So what does a good debugging process actually look like? Well, it's systematic. You always start with the data. Is it clean? Are the labels right? Is it imbalanced? Then you check your metrics. Are you even measuring the right kind of success? It's only after that, way down the line, that you start tuning the model and doing a deep dive on the specific mistakes it's making.
And of course, we can't have this conversation today without talking about large language models. Let's be real. Any candidate who isn't deeply familiar with this technology is already more than a year behind the market. It's a non-negotiable at this point.
So a modern baseline question is just to define RAG. It's a really key technique for making LLMs more accurate by basically giving them a cheat sheet of up-to-date external information before they try to answer something. Simple enough, right?
But here's the real test. Knowing what RAG is, that's easy. The much harder and more important question is knowing its limits. When is RAG actually the wrong tool for the job? For example, if you need the model to do some deep reasoning or get creative based on its internal knowledge, not just spit back facts, RAG might actually just be noise. Answering that question tests for judgment, not just memorization.
You want to really separate the people who've read the blogs from the people who've actually done the work. Ask them this. Getting an LLM's hallucination rate below 2% in a live system is a massive, massive challenge. A great answer is going to involve practical, hands-on experience with things like setting up guardrails to control the output, fine-tuning the model on very specific data, and building really robust evaluation systems. This is how you spot a builder, not just a reader.
But you know, even the most brilliant technical skills in the world aren't enough. Not even close. An AI developer who lacks good judgment and integrity, well, they can become a huge liability. So the final piece of a great interview has to go way beyond the code. So picture this scenario. You're under pressure. The big deadline is tomorrow, but you know deep down the model just isn't ready. Your product manager says, "We have to ship it." What do? The answer here reveals everything about a candidate's ability to communicate risk, to manage expectations, and to stand by their professional standards, even when it's really, really hard.
And this next one, this is so critical. You have to probe for experience with failure. The best engineers are the ones who have seen their models fail, sometimes in really unexpected or harmful ways. A great answer shows humility, it shows accountability, and it shows that they have a process for fixing these ethical blind spots. A candidate who says, "Oh, nothing's ever gone wrong for me," that is a major, major red flag.
And that really brings us to this key idea. It's not about finding someone who has every single answer memorized. It's about finding someone who has the right thought process. The candidate who can confidently say, "You know what? I haven't seen that exact problem before, but here's how I would start to figure it out." That person is infinitely more valuable and, frankly, safer than the one who just tries to bluff their way through.
And so that really leaves us with one final question for anyone out there who's involved in hiring. Your interview process might be great at testing what a candidate knows from a book, but does it test for what they do when things inevitably break, when they're under pressure, when the real world gets messy? Does your interview process test for the resilience it takes to not just build AI, but to truly own it?